Okay, this is chapter 11, lesson 2. We have to be able to change bases. What are we talking about with changing bases? Well, all of these are bases that are being put to a power. That's a base. That's the base. That's a base. That's a base. That's a base. Those are all the bases. And what are these little things up that are raised up? The exponents or the powers. Okay, so that's basically the two parts in the problem. Is the base is the number at the bottom, and it has this exponent sitting on it. All right. So if you're going to change the base, that's like this. Do you get that this 4 right here could be rewritten? Now, I could rewrite it as for something as simple as this. What's 4 the same as? Well, like 5 minus 1. There, I just changed the base from a 4 to a 5 minus 1. And you might be like, why would you ever do that? Well, they are the same, aren't they? 5 minus 1 and 4. Okay, so maybe there's a problem where that would help you. Today, what we typically change the base to is something like this. This problem, which was 4 to the third, could be changed into this 4. I'm going to undo it again and say, I'd rather have, what's another thing you think? Yes, exactly. 2 to the second there. And then it's 2 to the second to the third. And what is 2 to the second to the third actually equal to? 2 to the sixth. Do you get that that's actually exactly equal to this? And now I can tell those have to be equal to each other. That's called changing a base. What I do again, I change that 4 that used to be where I scribbled out in green, and I change that 4 to a 2 to the second. That's changing a base. All right, but we need to know these, and the ones that are most important are the ones that have the little stars by them. So I'm going to get all the way back to the way it was at the very beginning, which is like that. And let's just do the starred ones. What's 2 to the 5th? 32. If you don't have it memorized, memorize it now. And 3 to the 4th? 81. I can show you a cool way of why. Do you get 3 to the 4th is really this? And then it's 9 times 9. See? All right. 4 to the 3rd. 64. If you don't have that memorized, memorize it now. Of course, you could just do 4 times 4 is 16, and then 16 times 4, but that's kind of slow. This one comes up a lot. What's 5 to the 3rd? 125. If you don't have it memorized, memorize it now. If you have to, make yourself little flashcards for these, because you'll need them. 6 squared, 36. Why don't we do 6 to the 3rd? It just doesn't come up very much, because 6 isn't a really common base. 2 is a really common base. 5 is a really common base. 4 is a really common base. 2 is the most popular, though. 2 and 3. I'd say these get used more than anything else. All right, and then 7 squared, you should know that one. 49. You do not need to know 7 to the 3rd. It's just 49 times 7. We'll do it quick. 9 times 7 is 63. 28. 9, 34. 343. But again, it's not a big deal. A couple more. 8 squared, say it. 64. 9 squared. 81. Good. All right. So why do we care? Because if the bases aren't the same, we have to make them the same. But in this case, they're the same. Bases are the same. If the bases are the same, what would have to go there just to make this answer right? 8. Do you get that this had to equal this? So if the bases are the same, then the powers have to be the same. That's the rule. That's what we go for. So when the problem's like this, we try to make the bases be the same. They aren't right now, but we can force them to be. If we force the bases to be the same, then the powers will have to be the same, and that's where the answer is up in the power. Because the x is in the exponent. That's what makes this thing called an exponential. Let's say that again. An exponential is where the x is in the exponent. People get it confused all the time with this. We've already been doing these forever. Is that an exponential? No, because the x isn't in the exponent. It's not whether there's exponents involved. It's if the x is in the exponent. That's what makes these exponentials. Okay, so to solve exponentials, one of the easiest ways is make the bases the same. So you ask yourself, can I break up this number into anything to a power? Yeah. I can. So what should I put? 2 to the 2nd. Can I break up this number into, since I already picked 2, wouldn't it make sense to use 2? Okay, so should I make this 8 into 2 to the 5th? No, because it's not. What is it? 2 to the third. And once I've made the bases the same, see, this is the same as this, then it's almost like they cancel. They aren't canceling, but it's like they cancel. And what do you have left? A little equation. What's that? What do you do in that situation when there's a power to a power? Add them, subtract them, multiply them, divide them? Yes, there's going to be an equals involved, but what do you do to those two things? Multiply them. Multiply them. So 3 times x, 3x, equals 2. There we go. And now it's just a mini equation that you've been solving since like 5th grade. Seriously, they've been solving these for a long time. So you just divide by 3 and you got x equals 2/3. But wait, you say, you just are telling me that 2/3 is what I should put here. You mean exponents can be fractions? Yes, they can. So let me stop for a second and show you something about exponents being fractions. I know you probably have never seen that. Like, have you ever seen a problem like this before? Have you ever been asked to do that before? All right. Sounds like one of you have. Okay. Maybe 2. Okay. If you don't know how to do this, you will. And today I'm just introing it. You don't have to be awesome at exponents that are fractions, sorry. But fraction exponents aren't that hard if you get that they're really just 2 parts. This part is what root you should do to your base. And the roots go on the bottom, just like in plants. The other is your normal exponent. This is to the 3rd power, just like you'd expect. So you do 2 things to the 9. You take the 2 root, also known as the what? A 2 root is a what root? Square root. You take a square root of 9, and then you put it to the normal power of 3. And this turned into 9 to the 1/2 power. Maybe you never knew this before, but to the 1/2 power means square root of. And then you do a normal 3 as a power. Do you get this is exactly the same as this once you multiply it out? So I broke it up into 2 parts, the root part and then the normal power part. What's the square root of 9? And then 3 to the 3rd is, so the answer is 27. 9 to the 3/2 power is 27. You take the square root of it first, and then you put it to the 3rd. Let me give you another one like that and see if you can do it. 8 to the, no, let's make it the 2/3 power. 8 to the 2/3 power. Remember, roots are on the bottom, just like in plants. I don't know any plants where the roots are on the top. Interesting. I can imagine that might happen. The most unusual roots that I know of are, there's a cool plant in Hawaii. It's called a walking tree. And here's how its roots work. Let's say that there's this hillside heading down to a little gentle stream of fresh water. And if you were the tree and you were living on this hillside here, you'd probably be saying, geez, I wish I could be down right next to the water because I'd get more water, right? But these cool trees drop their roots down and they drop off the side of the tree that's on the lower side of the tree. How does it know? I don't know. But it drops its roots down off from, not in the ground, they come from the side of the tree, and they start dropping down slowly, and they grow and grow and grow until they touch the ground, and then they go into the ground, and then, believe it or not, the roots from here let go, and slowly over time, the tree gets closer and closer to the water. So after like 20 years, the tree's right on the river bank, right, getting fresh water. Isn't that cool? Okay, anyway. But the roots are on the bottom, so did you figure it out? This is the 3rd root of 8. That's 8 to the 1/3 power. And then this is a normal power of 2. That's what you should have done. What's the third root of 8? 2, and then you go, oh, wait a minute, some of you probably don't get that. The third root of 8 means like this. That means 8 to the power of 1/3. It's also known as the third root. It means what times what times what makes 8. And what is the answer? 2. So this part gives me 2. Why don't I just stop there? Because this part is 2, and then that says to square it. So the answer would come out on this one, 2, 4. Who had a 4 before I said it? Okay, good. Let's do one more like that. 27 to the 2/3 power. Figure out the answer, write it down, turn it my way. I'll tell you if you got it right. Pause while we try this one. You should have had 27 to the 1/3 first, and then to the 2. Why do the roots first? Because you always want to make it smaller first before you square it. Interestingly, it would go the other way. If you took the 27 and then squared it and then take the third root of that, it would have worked. But it'd be brutal. You have to take 27 squared, which not many people can do in their head, and then take the third root of this giant number, but it would have still worked. But it's just smarter to make it smaller first. So 27 to the 1/3 is the third root of 27, which is what? No, it's not. It's 3. It's 3. Then you square it, and the 3 squared becomes 9. See what just happened there? The red circle thing here, that was 3. And then you square it, gives you 9. All right, that's fraction powers. All right, and you're in an honors class, so we got to go fast. There's a lot to learn. All right, so get to this one. 32 to the x equals 1/4. So you ask yourself, can I make these into something to a power? And you can, but it's a little trickier. 1/4, could you make that as something to a power? I'll give you a hint. Start with this side, because it's easier. What could 32 be as a power? What to the what? See how having them memorized would be nice? I know this one. 2 to the what? 2 to the 5. So if that one's 2 to the 5, it kind of puts a little peer pressure on the other one to be a 2. Do you get what I mean? I need the bases to be the same, but it's a 1/4. How can you make that a 2 to a something? You can. Let them think. It's 2 to the something. 2 to the something. 2 to the what? What if I just wanted it to be 4? Then it would be 2 to the what? 2 to the second. What's wrong with that? It's close. It's 4, but it's supposed to be 1/4, so you make it -2. Get what happened there? 2 squared is 4, and then you make it negative, and that makes it flip. All right. Why was this good? Because now the bases are the same, and I can make them disappear. And my answer is 5x equals -2. What the heck does that mean? We'll just solve it. Divide by what? Divide by 5. -2/5. All right, I want you to try this one. It's the same idea. Ask yourself, what could I make as a base? And if the one side's too hard, do the other side first. Once you realize, oh, I guess it's got to be 4 to the 3rd, or the base has to be 4. In this case, it's not. Then figure out what both of them are as bases. Then set the powers equal. Then solve it. And then compare with the kid next to you. I'll pause while I pair you in groups. Okay, I heard a lot of good talking, which was helping each other with this, which is awesome. This one feels really hard to me, so I'm going to move to this one, which is easy to me, because I know that's 3 to the 3rd. True or false? Okay, so then that tells me I got to use a 3 over here. So then I know it's got to be 3 to the something. And then I go 3 squared is close, but then that's 9, and then I make it -2. So why can't I solve it right now? What did I do wrong? I forgot something. Forgot to bring down the parentheses, yes, and the x right there. There we go. Now I can solve it because the bases are the same. I make them disappear. Sounds kind of diabolical, but anyway, those two are equal. And the final answer is x equals 3 over -2. -3/2. Any questions on that one? Okay, they get scarier. But it's really not that bad. You can do it. Nothing jumps out at you, though, so at least you got that going for you.
I don't know, there's not black right there.
For me. So tell me how to do it, Mr. N.
All right, so I did 2
2 to the
to the 1,
2 to the 1 is 2. You're close.
-1.
There you go. 2 to the -1. I agree. Now what'd you make this into?
2 to the -2.
2 to the -2. Perfect. And now what do I need to bring down to make this thing right?
X, 2x.
2x. Excellent. And now that the bases are the same, I'm not really canceling, but it's kind of like canceling. And then keep going.
Left with -1 and 2x.
Which, when you multiply them, gives you
-2x.
Equals.
-2.
Perfect. And then x equals 1. And if you needed to know if you were right, like you thought you were right but you weren't sure, what you do is you take the 1 and you stick it back in the original problem and see if it actually works. If this is true, then I should be able to put a 1 here. That means 2 times 1 is 2. Is 1/2 to the 2 equal to 1/4? That's what you're saying, and is it? It is, because 1/2 to the power of 2 is 1 squared over 2 squared, which is 1/4. So it actually works. Now you know it works. Now you know x equals 1 is the right answer, so there it is. All right. Okay, moving on. This one, even more scary looking. Let me give you a hint. The base doesn't always have to be a single number. Sometimes the base is a fraction. Like 3/4 is your base. See if you can do it. Think of it as a challenge. You're in an honors class. You should be able to say, I want to try to rise to the challenge. You can do this. Your base is a fraction. So can I boil this side here down to anything smaller to a power? No. And if you can't, then that must be the base. If you can't make it any smaller, then it's the base. 5/2 is the base. So I don't even need to change the left side. It stays the same. The right side needs to be 5/2, and it's to the 3rd. But if I just write that, it's a lie, because, of course, that is not equal to that. But if with one little power right here, you put the right thing where the question mark is, you'll be almost done, because then the bases will be the same. Then you just set the exponents equal. Then you solve it. See if you can do it. I'll pause for a second while I give you one more time. Here we go. Let's see who had it right and who didn't. This has to equal this, and to me, those numbers are too small, so I got to use something like 2 or 3 to get them to be bigger. If I just use a 2, it'll turn into 25/4, which is close. So then what's the flip factor? Negative. So I put in a -2 here. No, don't start with that. That's different. Okay, these are gone now. And x equals -6 is it. Raise your hand if you had -6. Okay, good. Then, this is a little weirder looking, but it's the same process. Ask yourself, could I make this something smaller as a power? Yeah. And once you know the power, can I make that the same power? Yeah, you can. So try it. And it's really not that hard. It's just that a lot of people are going to make one little tiny mistake. Try to not be the person who makes a little tiny mistake. Because seriously, even this is pretty easy, half the class is going to get it wrong. I'll pause while you puzzle over that. Okay, so let's see. You should have been thinking, that 8, can it be written as something to the something? You don't have this one memorized. Memorize it. It's 2 to the 3rd. It's okay. You just don't have it yet. All right, it's all right. It's all right. And I know that these powers to the third power are not nearly as easy as like squared. So memorize it though. 8 is 2 to the third. And then that tells me this has to be 2 to the something. And 2 to the what would make it 1/2. 2 to the negative 1. And now what haven't I brought down yet? The x minus 1. That comes down here. And now the bases are the same, so they're gone. See if you can finish it.
So does that negative 1 multiply with the x and the negative 1?
That's a good question. You got to figure that out. Thanks for giving away the little thing that everybody gets wrong. I'll pause for a second while you see what you think it is. Okay, here we go. So I did get asked, could you use a different base than that? Yes. If you found a different base, like you maybe used 1/2 as your base, that's legal. But back to, I like 2s. 2s work as great as a base. 3s work great as a base. But you could have used anything for a base. As long as you make these the same as each other correctly, you'll be good. Now, did you actually figure out that that's negative x plus 1 equals 3? And therefore, negative x equals 2, x equals negative 2. Raise your hand if you got that one right. All right, more than half the class got it. Somebody gave it away. Yes, you had to multiply both parts. Everybody last hour just multiplied the first one by a negative. It's now that you know it, it's obvious, but it's easy to forget. You got to multiply that by both parts. Okay. Now, if you had done it with a different base, did you use who used the base of 1/2? All right, and did you guys get the same final answer? Cool. You can verify that that does work. If you get negative 2 for the answer, you're good. Okay, this one, really scary looking. Hardest one we're going to do. Give it a shot. But it's not that hard, really. It really isn't. They can be. I know you want a challenge, but for right now, just answer that one. Pause for. Okay, so we figured out that this right side can't boil down into anything smaller to a power, so 3/7 has to be your base. Then it comes down to, can you make that into 3/7 to a power? If you can figure out the question mark, you're pretty much done. I'll pause for a second while you try to finish. Okay, let's finish this thing. The question mark. What is the question mark? Well, I have to make it bigger. Just take the logical things like 2 or 3. If I just square it, quiet please, quiet please. If I just square it, in back row, please be quiet. Thank you. If I just square it, it'll turn in a 9/49, which is upside down. How do I flip it? And you've seen that a lot of times, right? Now it's going to keep coming back, and they keep doing that to you. So watch that in the homework. That's gone and that's gone. So this equals that. Negative 2x equals 3/2. Okay, so now if I want to solve that, a lot of people were stuck on what to do here. There's 2 ways. One way is, do you remember me saying if there's fractions in your problem, clear the fractions? So I could multiply everything by what? 2. That's a smart way to do it. You don't have to do it this way, but I like it because then my fractions are gone and my problem's easier. Negative 4x equals 3. And from there, even a child of age 9 can solve this. Divide by negative 4, divide by negative 4, and it's negative 3/4. Okay, but is there another way to do it? Yes, but do you get the same answer of 3 negative 3/4? Yes. Oh, you think there's another way. All right, so hold on. Let me back up to this. Would you, yeah, hold on. Up to here, were you the same as me? Negative 2x equals 3/2. Okay, now tell me what you think we should do.
So then I divide by negative 2.
Divide by negative 2. Wait. Divide by negative 2. Okay, wait. Now we agree that those cancel, and that's an okay way to do it, but I'm not sure you simplified this part right. Go ahead.
But then you're going to actually, like, 3/2 is actually, like, times negative 2, 1.
Okay, but remember, it's dividing by, can I put a divided by 1 right there? Would you agree with it so far?
Yeah.
I can just put a divide by negative 1. Do you get that dividing by negative 2 over 1 is the same as multiplying by 1 over negative 2? You gotta flip it. X equals 3/4, and it's negative. So it was negative 3/4. You're just making a little mistake in the dividing by the fraction. Okay, so that's what you have to do for tonight. Your homework for tonight is fairly small. It's in the smartboard. It says you have to do the Schoology quiz. You do not. Just do the worksheet for tonight. Show some work. I'd like to put another thing in the grade book tomorrow, so have this done. Have a great day.